student, this is the video lecture on linked list. My name is Drashti Mori and I am the professor from New LJ Institute of Engineering and Technology. I welcome you all students, and this is the last video lecture where we are going to cover implementation of stack using linked list. Then after we implement a queue, and then we will see application of linked list. Now, as I said, when I want to develop a stack from using the linked list, first of all, you have to understand the complexity of your data structure. When I say linked list, if I want to insert something in your linked list, it can be a first node or it can be a last node or it can be a in between. So in that case, your time complexity when I want to insert your linked list, it would be in terms of O of n. Yes or no? But when I say stack, in stack, you have two operation, push or one is pop. So when you want to add something, that operation have constant amount of time. So what would be the insertion and deletion time complexity for the stack is O of 1. So if I am able to convert my linked list operation where the time complexity of insertion deletion are 1, am I able to say that I created the stack using my linked list? So what can I do for the mechanism where I have constant amount of time? When I say I want to create a stack using linked list, first of all understand, in a stack we have a one pointer which is known as the top, and top will always point to the top of the stack. In our case, consider this is my first and last node, and this is the only node in my linked list. Then their pointer part will have null, and top will point to the n1. Now consider I want to push something on top of my n1, so that node become my n2, and that node will have the link address of what? Link address of n1. And now my updated top would be here. This way I can perform the constant amount of operation using my top pointer. Fine or not? So that insertion operation is known as a push. Likewise, if I want to delete something from your linked list, which node should I delete, n1 or n2? In the case of stack, we always able to remove the node which are at the top. Yes, here n2 are at the top and n1 are at bottom. So in pop operation, I am able to delete my n2 node. For deletion, which operation I need to perform? First of all, I need to update the top link to my n1. How can I able to update my top pointer? I just have to traverse the top. How we can traverse? Traversal step is top would updated with link of top. This way I am able to update my top link, and now n2 would be the node which need to be pop out. So whatever data are here would be displayed on your screen, and whatever operation you want to do you can perform. So this way I am able to create my stack using the linked list. Let me erase all this thing and try to understand with one diagram. This is the representation of one linked list which have the which is work as a stack of 25, 32, 50 and 99. So 99 is the topmost element, and this is the stack, and their pointer is pointing to the top part. Now I want to implement the stack, and for that I require the push as well as pop operation. Now consider the implementation of push operation. When I say push operation, first of all check, do my stack have empty or not? If it is an empty stack, then last node, it is a last and first node, it would have the link part null. So I have to set this thing, and for that I require to check that top is null or not. Yes, if top is null, my link part of newly created node have the null. And if it is not the case, then link part of the new node should point to the existing top. If I want to add something on top of 99, consider I want to add something in top of 99, then your link part would have address of your top pointer, because top is right now pointing to 99. So this new node have to be point to top. So write down that step in else part. And after that, what should we do? We updated the link. That link of new node would be null or it can be a top. Then after, make a top as a new node. Now top would point to the newly added node. So top pointer need to be updated in your push operation. This is the end of your push operation. This is the algo part where you have to write down the step which you can perform to implement the stack using your linked list. Now one more operation, that is pop operation. When I say you have to implement the pop operation, which thing I require to check, do I have a node or not? If I don't have any node in my stack, then am I able to pop? No. So check. If top is pointing to null, it means your stack is empty and return from that stack. Else, what you can do? You just take the value which are at the top in my temporary pointer. Yes or no? The temporary pointer have the location. Consider the case where I have top here. And now I created the one temp. These are also pointing to the 100. Fine or not? Now I need to push down my top pointer. Top pointer should now point to the 99 because I want to remove the 100. Fine or not? And for that, what can I do? Top would have the link of top. Yes or no? So this step would like top will be updated with link part of top. This way I can step one down. If I am here and if I want to delete 99, what can I do? I update my top with the help of this pointer. And this pointer is pointing to here. So now updated top would point to the 50. This way I can able to implement stack. Yes or no? Now, if I want to implement a queue, it is not a stack, it is queue. If I want to implement a queue, then what operation I need to perform? I maintain the two pointer. First add one pointer which is pointing to the node which are the linked list first node, and one pointer need to point to the last node of your linked list. Yes. So from where I should insert or from where I should delete? This arrow is pointing to 99 node is pointing to 50 node, 50 node is pointing to 32 node, and 25 pointing to nothing. But it is a last node. So where is 25th node? Now I want to insert something. What operation should I do? I make a new node, update the information part. Then after I will update the link part with null. And here I want to update the address, and it should be address of this new node. Whatever the address of this new node would be updated here, and this rare pointer now have to point here. This way I can able to insert in my linked list. Yes, and this operation is known as a enqueue operation. Please try to understand. I am inserting some new node from the rear. I am not adding something from the front. I am adding something from the rear. So this way the queue operation works. And if I want to delete something, then for that, if I want to delete the 99, as Q says, from one end you can add and from another end you can delete. So here I am adding something. So from the other end, which is the front end, from front end I will delete my node. So if DQ operation are being called, 99 node will get free. And for that, which operation I need to perform? I simply update my front pointer to the next node, and that address will be get from here, right? So front is updated with link front. Yes or no? Front would be updated with link front. Now check our algo step. When I say we want to enqueue, you just check that my string is empty or not. If my queue is empty, then what operation I need to update? Because my linked list don't have any node. So whatever the node which are in enqueue is the only node. So front and rear both the pointer pointing to my newly created node. Yes or no? And that new node link would be null. And if it was the case, then what you can do for enqueue, you have to update the link part of rear. This is what? This is the link part of your rear. It will be updated with what? New link. Whatever the new node, that value would be copied here. Fine. So this way I can perform the enqueue. And now I want to update my rear pointer. For updation of rear pointer, what line should I write? Rear would point to new node. Yes or no? As linked list last node must have a link to null. So this thing I need to add at the last. Now, as I say, I want to DQ operation. I require to develop the DQ operation. For that, I require to check my linked list is empty or not. In case of empty linked list, I am not able to DQ. Yes. So you just write the message that it is underflow. In the case of DQ and everything is okay, what you can do? You tag the value of whatever here in a temp. Temp will get their value from the link info of front. So whatever here 99, 99 will be copied in your temp. Fine or not? Then after, if front and rear are pointing to the same node, in which case front and rear will point in a single node. If in a case where I have only one element in my queue, at that time front or rear, both the pointer are pointing to the same node, and this node have link address null. And if I want to delete this, in that case, after deletion of this node, front and rear should point to what? Nothing. Nothing means null. So this thing I need to update, that front and rear both should now point null, because this node would be going to be DQ from your queue. Fine or not? And if it is not a case, then what you need to do? You just have to traverse in your with the help of your front pointer. Now front would be updated with link of front. Now front will point to the 50 instead of 90. This way I can able to perform the DQ operation. I hope this point are clear. Now application of linked list. First we right now see how we can implement stack and queue with the help of linked list. This is the important application of your linked list. Linked list give me the strength that I can able to develop my stack and queue. And stack and queue can also be implemented with help of array. Fine. Now whenever I require some dynamic memory allocation, that type of application have to be developed with the help of linked list. So third application is whenever required to maintain a directory names. This directory name might not have be a continuous memory allocation. At that time, linked list can be helpful. Now we all know about the sparse matrix. Sparse matrix is a matrix which have more number of zeros. So in that case, I can represent the sparse with the help of array as well as linked list. One more application of linked list is I can able to represent my any graph. When I say any graph means, here I take the example of adjacency list. I will explain more what is adjacency list and all. I am able to represent my polynomial with the help of linked list, and this representation will help me to manipulate your polynomial. Fine or not? This last two step I will explain more in detail. Now, as I say, adjacency list is a one representation where graph would be represented with the form of linked list. Here, it is a list where each and every node have the connection with which node are being defined. Here, 0 is pointed with 1 as well as 4. So, in a 0 linked list, it have node 1 and 4. In a 1 node is connected with 0, 4, 2 and 3. So, they have all the connection. And at the last, it is the last connection. So, we are representing them with the null. So, this way we can represent the adjacency line, and this can be helpful while we want to do some operation. Like if it is a weighted graph, if I have some value that this link have weight of 8, this link have in the normal case, if you consider this is a city map, 0 city and 1 city have distance of 8 kilometer, 0 and 9 have the distance of 80 kilometer, whatever that. In that case, this representation will give you the strength to solve this type of problem. I hope adjacency list is able to understood. Now polynomial representation. Here I define one node. This is the single node that where first data have the power of x and second data have the coefficient of x. So representation of this polynomial should be represented with what? First node have the address which have the value 3 as a power and coefficient as 4. Likewise, second term should have the power of x as a 2 and coefficient of x as a 5. In a last node which have power of x is what? X have 0 power. So power of x is 0 and coefficient of x is 10. So this is the way I can create a linked list having a 4 node and represent this polynomial. You can represent different type of polynomial with the help of linked list. Consider the case where you have 3 variable. In that case, how you can represent it? Here, first data would have the power of x, second data would have power of y, third data would have power of z, and coefficient of, here you can write coefficient of term, not a x, it is term. Fine. So this way you can represent any polynomial with the help of linked list, and after representation you are able to manipulate it as well. Let me give you you can trace this diagram from your end. It is very easy to represent the polynomial. And this is the end from my side.